Hi everyone, I'm David. I am on the data engineering team at Tinybird. I'm based in New York, but come to Austin often for events like this, so really happy to be here. So what are we actually going to be doing today? We're going to be focusing on real-time analytics and going to be using gaming as our use case here, but everything we're going to talk about is not just limited to gaming. It should really apply to all industries. I'm going to give a quick introduction to Tinybird. I have just a couple slides, but I'll try to speed through them so we can get to the hands-on part. And then game time. So, first of all, what is real-time analytics? It's a total buzzword, so what does it actually mean? So I define real-time analytics as these use cases that serve hundreds or thousands of concurrent requests at millisecond latency over seconds fresh data. And these are often user-facing analytical applications, so things like in-product dashboards or real-time personalization or alerts. These are fundamentally different use cases than, say, like an internal Tableau dashboard, and that really requires different technology to solve them. So real-time analytics, again, is relevant to pretty much every industry, so why focus on gaming in this workshop? I find gaming interesting simply just because of the amount of data being generated by games. Every interaction in a game or on an application is captured as an event, and players need to make split-second decisions over the most up-to-date data. So we're going to be focusing on personalization and a kind of real-time segmentation, and the ultimate goal of personalizing the user experience, or the player experience in this case, is to keep people coming back for more, and also to drive revenue. If you can learn which of your users are likely to spend money or click on ads, when they're likely to do that, that gives you a lot of power to drive more revenue and actually turn data engineering from what's kind of historically just a cost center in a company into a profit center, into something that can actually drive revenue. So if you think about any game that we all play, like Candy Crush or whatever, every time you finish one of these games, there's a moment where you, as the user, get to decide what to do next. So, if I'm playing Candy Crush and I finish one game, I come to this kind of middle page sometimes where I didn't win anything. It just shows me all the levels. But the next time I win around, I get to a page like this on the right that I may get shown an ad or an offer for in-game currency or some kind of reward that I can use to kick some ass in the next game. I'll probably spend a couple of seconds, maybe 5 to 10 seconds on this screen, and that's a really critical moment for us as engineers to meet the user at that moment. We need to choose what to incentivize the user with so that we can keep them coming back and playing more, and also maximizing whatever offer for revenue. So how do people typically solve this today? A lot of companies try to solve it by adapting their existing batch stack, and it could look something like this. This is probably not exactly what you may have seen, but you might have some kind of data streaming tool like Kafka that is sending events to your data warehouse. You might have a data modeling tool like dbt to run transformations on some kind of batch. To ensure low latency, though, you'll want to ETL that data out of your data warehouse into a low latency store, like Redis or Postgres, depending on the use case. And then, of course, you'll have that back-end API layer to actually serve requests. And this stack has a lot of benefits. It does give you a great view of all of your users. The data warehouse is meant to have all of your data in one place. And it can be used for other things like BI or data science. But it has some drawbacks. All of these tools amount to cathedrals of infrastructure, as we like to say. And all these different tools also have different teams that manage them. And so this is a lot of different handoffs between the tools and the teams. And the result of this is kind of a slow rate of development and experimentation for building new use cases. There's also, of course, the cost of having all these tools and of all the teams. And really, every step here is adding latency and complexity. And really what this means for the use case that we're talking about today is that you lose that in-session opportunity. You miss that critical moment where you want to meet the user. Maybe you can apply what you learn in the next game, but not in that moment. So all of these tools serve a great purpose, and they're all designed for certain things. But for real-time analytics, this really ends up being the wrong tool for the job. And so imagine instead if you could ingest streaming data at scale, think of a new way to segment or personalize users or some other use case, and model it and deploy it based on those real-time events and also historical data, and then serve your APIs directly from that same platform. This would let you meet users at that moment and really speed up your rate of development. And this is why Tinybird exists. So Tinybird is a real-time analytics platform for data and engineering teams that lets you ingest streaming or batch data, transform your data just using SQL, and with one click turn your queries into API endpoints so that you can easily integrate real-time analytics into your applications. Of course, we're going to use Tinybird today, but I really don't want this just to be a sales pitch. I really want to focus kind of on the principles of real-time analytics, and they really should apply to whatever tool you may be using. So just quickly a little bit more about Tinybird. Under the hood, Tinybird is powered by ClickHouse. And for those not familiar, ClickHouse is a really powerful open source OLAP database. It's designed to give you sub-second latency over billions of rows of data. But it's really complex to manage yourself. And so Tinybird is sort of a managed version of ClickHouse. With Tinybird, you get all the power of ClickHouse, but you don't have to worry about provisioning and managing infrastructure. But we're not just a managed database. So as you'll all see, the real power is in the developer experience. You don't need any kind of specialized skill sets. We try to make it really easy to bring your data in and then just use SQL to build data products. All right, so what are we actually going to be doing today? I hope everyone remembers from a couple years ago the phenomenon of Flappybird. So we actually rebuilt a version of Flappybird, and we are all going to be kind of revamping the analytical backend of Flappybird to add real-time analytics. And that's going to come in the form of two use cases. The first is what we call user-facing analytics or in-product analytics. And this is basically going to be like a live leaderboard in the game. And the second, if we have time, is going to be this kind of real-time personalization that I was talking about. So let's get into it. If everyone just wants to go to that link, we can spend a couple minutes actually playing Flappybird. And let me mirror my display here. Okay. And also, please jump in whenever you want, raise your hands, or just call out. I would love for this to be as interactive as possible. So I will pull up Flappybird here. So I'll just play a couple rounds just to show everyone how it works. Oh, I hope everyone remembers how to play. You just use spacebar or enter to fly through the pipes. And then I'll die here. What's actually happening here, and I'll show in a second, is that every time you score, it's streaming an event to Tinybird. And then when you land on this page, you can actually see the live leaderboard. So we're streaming data to Tinybird, transforming it in real time, and then this page is making API requests to Tinybird. So you can see the leaderboard, you can see your own personal stats, and some of the recent games that you played. Also, the actual instructions for the workshop are linked right here at the top of this leaderboard page. So if everyone just wants to click on that, that will bring you to a GitHub repo. So let me actually open up the developer tools, show you what's going on here. So as I score, you can see that the events are streaming to Tinybird. And then each one of those events has, I can't see here. Here it is. Each one of those events has some data in the payload. So it has, of course, my username, the session ID of that game, the timestamp of each event, and then the type of the event. And then when I land on this leaderboard page, this is making several API requests to Tinybird. So for example, the leaderboard is making this API request here, sending my name in the payload, and that's why I can see kind of my personalized leaderboard. And then in the response, we're getting that data returned back in JSON and using that to populate the front end. And I don't know if anyone has been really bad at this game and has gotten a personalized offer. Has anyone seen that? That's kind of the real-time personalization, so I think I should get one here as well. I built some logic based on your performance in the game that if you play a certain amount of games and don't reach a certain amount of points, then to try and entice you to stay with the game longer, I give this personalized offer to activate easy mode. which I then use in the game code to make the gaps in the pipes bigger. So this is all about driving retention. You can, of course, see how you can start monetizing that. So this is what we're going to be building today. If everyone wants to open up the repository, I'm going to walk through it here, but all of the instructions are in that README. So if you'd like, feel free to jump ahead. Is everyone ready to go? Cool. All right, so I'm just going to scroll down. So we've already all played. So the first thing I'm going to do here is create a new Tinybird workspace. So I'm just going to click on this link. And it will probably prompt you, if you haven't already, to sign up for Tinybird. You just need your email, nothing else. And then I'm just going to rename this workspace. I'll just use my last name. Everything else I'm going to leave blank, and then I'll create the workspace. And a workspace in Tinybird is basically just a logical way to separate out your projects. This is where, as you'll see, your data sources and pipes will live. And typically we see people creating separate workspaces for separate use cases. You can invite other people to your workspaces and collaborate on projects. Okay, so I created a workspace. Next thing to do is actually start generating some data. So the first thing that we need to do is actually create a new data source. A data source is basically our representation of a table. So I have the data source here. I'm just going to navigate to Tinybird data sources, and we're going to use this events API file. And this will basically define your schema for the data source. So I'm going to download this. And then in Tinybird, I can simply just drag that .data source file, import the resource, and now I have an empty table that we're ready to start sending data to. All right, so let me back up here. And please tell me if I'm going too fast.
Events API?
Sorry?
Under the events API? Sorry, we're creating this data source where?
Yeah, so if you just drag it into, like, you should be able just to drag it kind of in the middle here. All right. So now we got to start sending some data to that. Oh, actually, before I even do that, so dragging that file also added a token. And this is what is going to authorize the request that we're going to use to post data to that data source. So I'm going to navigate to tokens, and I called it app append token. And you can see here, I granted it access to that events API data source. So I'm just going to copy this, keep it in my back pocket. And then to actually generate dummy data, we built this open source tool that we call Mockingbird, so that you can use to generate fake streaming data. So I encourage you all to use it for your own projects. And just clicking on that link, it will fill in all this information for you. And basically, this is just telling it the region that we're using, the name of that data source, how many events per second, and so on. All I'm going to have to do here is paste in that token that I just copied and save it. And actually, before I even go on, in this workshop, we're going to be using what's called the Tinybird Events API, just a simple HTTP endpoint that you can post JSON to. But you can think of it as kind of like an alternative to Kafka or some other kind of streaming tool. If you're using a streaming tool like Kafka, it works really nicely with Tinybird. So now that I added that token, I'm just going to click preview. This is the data that we're going to be actually streaming to Tinybird. So you can see every time you click preview, it's giving you some different values. And then I'll just click start generating. And this is going to start posting data to that events API, to that data source. So now, when I go back to Tinybird, if I refresh this, now you can see that we are ingesting some data into this events API data source. Any questions so far? Okay, awesome. All right, so now we have streaming ingestion in Tinybird. Great. Okay, so the next step is to actually write some queries and build some API endpoints. And the first one we're going to do is essentially to rebuild the leaderboard. So the way that you build on top of your data in Tinybird is through pipes. Pipes are kind of like a Jupyter notebook, but for SQL. This is actual SQL interface where you're going to write your queries. And you can break down your queries into easily digestible chunks here. Okay. So I provided the queries here that you can just copy and paste. So this very first one is just going to select a couple columns from that events API and just filter on those events that are scores. You can also open up the data source and split screen so you can see what data you're building over. You can view the schema and so on. Okay, and run this, and you can see the result there. And then I'm going to rename this node to filter data. When I scroll down, you can see that there's a new node that's selecting from that previous node. So this is that kind of notebook user experience where you can, again, break out your queries incrementally. And there's no magic here, honestly. This will still run as one big query. It's just an easier way to logically break down your queries. So now that we've filtered the data, now I'm going to aggregate it. And so this is simply just selecting the player ID and the session ID and counting up the number of rows to get the scores, since we already filtered on those types that are scores. Ordering by score in descending order, and then limiting just to the top 10. And because I'm using this Mockingbird tool, you see data is constantly streaming into the background. So every time I run this query, you can see that the leaderboard is actually changing. We're always running the queries over the freshest data that's streaming in. I'll rename this to, I think I called it aggregation or something. And now that we have the final query, the last step is to publish this as an API endpoint. Yeah, question?
Quick question. When you press run again, it's just computing the delta, or you're basically visualizing a view on ClickHouse, so the underlying engine just
Yeah. This query is just running over the entire table right now. So as new rows are getting appended, it's also running over that entire table. So it's not just the delta. Yeah. This is just a query on the raw data. We're going to get to materialized views in a second. You can materialize this data so that your aggregations can kind of be in real time. But just in this one query right now, it's just querying over the raw data. Okay. So the last step here is to publish this as an API endpoint. And it's simple as clicking create API endpoint, choosing which node to publish, and boom, there's your API. And so showing this working in real time, I'm just going to copy the URL and paste it in a new tab. And every time I make a request to this API, it's actually running that query and returning the results here in whatever format I defined, which is JSON. So you can, again, see every time I'm refreshing the page and making a new request, the values are changing. And then just back in Tinybird, you can see all those requests that I just made in the past couple seconds. All this log data that's captured is actually available to you to query. A lot of our customers kind of get really meta with it and build APIs over their API logs so that you can monitor how everything is performing. All right. So there's the first API endpoint. Questions? Comments? Cool. Let's move on.
Is there a WebSocket implementation for the endpoint? Do you stream to the browser?
No, I don't believe so. Let me show right here. So we just have this events API. So let me back up. So if I click create new and go to data sources, these are all of the different native connectors that we have. So before I was mentioning Kafka, Confluent, and so on. The events API here, it's just a simple HTTP endpoint that you can post data to. All right. So now that we created that first endpoint, like we were just talking about, that endpoint or that query is just running over the raw data. And it's pretty performant. I think we're saying 20 milliseconds, which is nice, but this is only a couple thousand rows. So not very impressive. As your data scales up to the millions or even billions of rows, this query that we wrote would probably come to a screeching halt. So the way to optimize queries, or one of the main ways to do that in Tinybird, is through materialized views. And materialized views, of course, not a new concept. But in a traditional database, you have to schedule a materialized view to run. And typically, those queries would schedule it every, 5 minutes, hour, whatever. And it would run over the entire table and then update the final result. What's unique about materialized views in Tinybird is that data gets materialized on ingestion. And basically, that means that you have real-time materialized views. So let's build one of those. The way that you create a materialized view is exactly the same way that how I showed creating a pipe. So I'm just going to copy this query here, and let's create a new pipe. So this is simply, again, just selecting a couple of columns, counting up the score, or doing this aggregation, and also just getting the latest timestamp for each game so we can see when that game ended, and filtering on the scores. What did I say to call this? Match player stats. And I'll rename this to MV. So instead of publishing this as an API, instead I'm going to create a materialized view from this. And let me rename this to player stats MV. There are a couple configurations that we can set. So one is the sorting key. This is essentially the index by which your data is stored. All that looks good. I can click next. We can choose how much data to populate the materialized view. I'm just going to leave 2 million rows because we have less than that right now. And then I'm going to create it. And before I move forward, let me just back up to this pipe. You may notice that a couple of changes happened automatically. So these aggregate functions that I have, Tinybird automatically added these state prefixes. And this is essentially how Tinybird does these real-time materializations. Whenever new data hits this events API data source, it will automatically trigger this query to run, this transformation to run, just over that new block of data, and it will save the intermediate state of that aggregation. So that's why I see state here. That's also why, if you look at the new data source that's populated, you see some blanks here or some weird symbols. This is basically just the representation of that intermediate state. All right, now we have to query from this materialized view to build an endpoint on top of it. Okay, and so I'm going to copy this query, and I'm going to create a new pipe from this. So now we can treat this just like any other data source. So selecting the player ID and session ID, and now we're adding this suffix to merge those intermediate states. The materialized view does have an asynchronous process that runs in the background to, I think, every 8 to 10 minutes or so, does merge those intermediate states. But you don't necessarily know when that's going to happen. You can't rely on that to happen whenever you're going to query it. So since we're working in real time, you need to sort of force that merge to happen when you're querying the data. So that's why we add this merge suffix here. And now when I run this, we have, again, our final result. And you should be able to see that every time I run it, I guess maybe, I don't know, maybe we have just the top 10. But this materialized view is being kept up to date in real time. And so this is actually querying all of the freshest data that's streaming in. And now, let me rename this, call it like leaderboard from V. Now can publish this as an API endpoint. And again, we can make requests to this. And we see all the latest values here. Any questions? Is everyone able to keep up? Am I going too fast? All right, awesome. Okay. Let me make sure data is still streaming in. Yep. Okay, great. So we basically now just created 2 different API endpoints. One that's running that query over the raw data, and then we optimized it through materialized views. Since we got through that pretty fast, we can now tackle that next use case, which is that real-time personalization. So I left this one a little bit more open-ended. Hopefully everyone's been following along close enough and is able to actually build something themselves. And so for this real-time personalization, again, this is that use case that is going to provide that personalized offer that I'm using here to, if someone's struggling in the game, help entice them to keep coming back and playing more. And maybe at the end of the day, we can monetize that. So I'm going to stop sharing for a minute. And if everyone wants to just spend a few minutes trying to build this personalization themselves. And I'm happy to walk around if anyone has any questions. Yeah, just raise your hand. I'm sorry? Yeah, great question. So when I published the API for the first time, you can see we automatically added this authorization token. We include this by default just so you can immediately start building on top of it. Because Tinybird, we're all about kind of trying to increase your speed to production to get you to move faster. So this one authorization token just has access to this one pipe. But you can define your own tokens that can have as broad or as granular access as you want. So, for example, I can create a new token here, and I can give it access to multiple pipes. I can also add in certain SQL conditions. So, for example, if I give it access to this one data source, I can define a SQL condition that is name equals David. Test that, looks good. Add it. And now this token will essentially allow me to do a kind of row-level security, because this token will only have access to rows in this data source that have name equals David. Does that answer your question? And a lot of we do have clients that are using these tokens directly in their applications. We have an API, a tokens API, where you can programmatically manage your tokens, create new ones as new users are created, refresh them, and so on. But a lot of our users don't necessarily want to include a Tinybird API directly in their front end. So often we see people using some kind of API gateway or some kind of proxy by which they can make requests in their back end, obfuscate the tokens and whatever else they don't want to share, and then publish the results. Any other questions? Has anyone already built the personalization API? I'll take that as a no. So another thing, I think I mentioned it in these instructions somewhere. For kind of the first pass at these APIs, and this is how we tell our customers to work, this is how I work in Tinybird, is always first build those queries, those APIs, over the raw data, and then use materialized views to optimize, and other methods for optimization. All right. So I'll start sharing. And is anyone brave enough to share their solution if they come up with it? Will, I'm looking at you.
New Jersey.
All right. All right. So essentially for this, I'll show my solution here. Or I'll show kind of my whole thought process. So what we want to build here is we want to be able to filter on a specific player, and based on their performance, either give them an offer or not. And so those conditions is going to be based on the last hour, if they've played 3 or more games, scored a certain amount of points, and made 0 purchases. So a purchase event comes when you click on that claim offer button in the game. So first thing I want to do is actually just filter on a certain user. So I'm just going to pick a random one here, just as I'm building this out. And then I'm going to calculate, first, let's group everything by session first. No, I don't want to filter. Yeah, so let's first look by session. I'm going to use this count-if function to calculate the score. I don't want to just filter on the type equals score, because I also want to get those purchases. So if type equals score, I'll call that scores. And if type equals purchase, as purchases. Okay, great. I'm going to rename this to filter data. Another condition that I need to add is the time filter. So I said here, I only want to look at games in the last hour. So I'm going to also filter on, what do I call it, timestamp. And I'm just going to use this notation, now minus interval 1 hour. This is essentially just like doing between now and now minus 1 hour. Okay, great. So now for each game, I have the total score and if there's any purchases. This dummy data may not make much sense if they did not score but made 2 purchases, but we'll roll with it. Okay, so now that I filtered that, why don't I aggregate it? So first I'm just going to do a count of all of these rows, and that will give me the total number of games. Sum up the scores, total score, and sum up purchases. There's likely a more optimal way to do this, but typically I just like to work and get a working query, a working endpoint, and then work backwards to optimize. As total purchases. Okay. And now I can finally add this logic to determine whether to give someone an offer or not. So I'll just do a simple if statement. If n games is greater than or equal to 3, I think I said. Yeah, 3 or more games, less than or equal to 15 points and 0 purchases. Okay. And total score, less than or equal to 15, and total purchases equals 0. Then let's say, I'll just do 1 for yes, give them an offer, 0, no offer. All right. And there's a result. So this one player that I filtered on, since they don't meet any of the, or they meet the game condition, but they scored more than 15 points, they should not get an offer. Before I publish this as an API, I'm going to back up a bit here. And since we want these APIs to be dynamic, I don't want to just hard code this filter on one user. So instead, I'm going to replace this with a query parameter. And you can see here that there's this button, how to add a parameter. This will give you some little snippets. I'm just going to be using the most basic version of the query parameter, which is just to filter data. But you can do a lot more advanced things like conditional statements. You can throw custom errors. There's a million things you can do with this. But I'm just going to use this filter condition. Copy that. So I'm defining a string parameter. And why don't I just call this player param. And I'll give, I guess, that name as a default. And so you see the actual value, or the actual result of this did not change. But now at the top, you might have a separate view, actually, but it should look something like this. You can actually see the parameter that is defined. Tinybird detected that you added a dynamic parameter. Yeah, I think this is a new feature we're rolling out, so yours might look a little bit different. All right, so now I'm going to publish this as an API endpoint. And why don't I just show it working right here? So you can see in the URL now, we have that query parameter. And so I can now use this and change the value. I don't know what the names in this dummy data look like. But there's a million in there. Did anyone solve this in a different way that they would be willing to share? Or has anyone already made it to the materialized view version of this? No? All right, let's move on to that then. Any questions before I move on? No? All right. So last step here is to optimize this query. Same thing as I said before. This one endpoint is just running over the raw data, and as we scale up, this will get too expensive. So let's create a materialized view. I could probably reuse the materialized view that I created in the last one, except I did not add the purchases. So I am just going to create a new one here. I'm going to copy this because it does have most of the same information. So I'm going to use count if type equals score, and just copy that. Type equals purchase as purchases. Okay. Let me just make this max. Okay, and I'm going to call this, mat stats 2. Not the most descriptive name, but again, let's just stick with it. Okay, so now I'm going to create a materialized view from this query. I'll leave the sorting key the same, and since I'm going to be filtering primarily on that player ID, it makes sense to have player ID as the first field by which our data is sorted. Stats. Next. And I'm just going to select previous and new data. So this is basically just all of the data we have. We only have about 125,000 rows, but imagine you already have millions. Create this materialized view. And this should already have some data. And now I can start building this pipe on top of it. So again, first thing I'm going to do here is filter on player ID. And I'm going to add in that query parameter right away. So let's call it player param. I can give it this default value. I can add a description for documentation purposes, so player to filter on, and also for documentation I can say if it's required or not. So run that, looks good. And I'm also, let me sort of re-aggregate the data as I showed before using the merge functions. So I have to use now count if merge. Scores, count if merge, purchases as purchases. Oh, I need to add group by session ID. And I need to add the end timestamp. Okay, awesome. So now for our one player, Adonis, but again, this dynamic filter. We have all of their games and their scores, and now just like I did previously, I can do my aggregation in the next node. So again, I'll just count up the number of sessions as the games, sum scores, total score, sum purchases, as let's just call it P. And I can filter where TS now is greater than or equal to now minus interval 1 hour. And then I can add back in that offer logic the same way I did before. So if n games greater than or equal to, why don't I just really inflate this just so we can see someone that does get an offer. So greater than or equal to 3, and total score less than or equal to 50, and purchases are, let's say, less than or equal to 10. Then 1, yes, you get an offer, 0, you don't get an offer. There we go. So this one player does get an offer. And then last step, publish this as an API endpoint. And that's about it. Thank you all for your time.